Hello again from Skip, Victor Echo 6 Bravo Golf Tango. So this is another project that I've been trying to get back onto for the last couple of years. The new 13 centimeter feed. Difference being from the old one is it has the newer or better IMU launcher section on it. This original feed was built to, it had this square frame around it, and it was made actually for my very first dish, which only supported the old 1296 septum. So there's a square mount, and there's no easy way of replacing feeds on that dish. So I just kind of modified it to fit the new one. Then later I changed dishes over to this expanded 12-footer, and I came up with a better idea for the dish holding frame or mount or whatever you want to call it. And of course the scalar ring had to be changed for this dish also. And the new dish mounting frame or holder, which I want to call it, it worked well, and I merged it onto the newer 21-foot dish. And then on this picture here, you can see where I changed the scalar ring to match the much shallower 21-foot dish over the smaller, deeper dishes. But I wasn't happy. I still wanted to change things. One problem with the large scalar rings was putting the feed into the dish. I have to lean way out front because I have to come in from the front side of the holder. It won't slide through my narrower frame mount. So that was another thing I discovered. I liked about using it on the smaller feeds. Smaller feeds with the IMU launcher would slide into the holding frame of the dish just perfectly, and they're a little more complex because they have the amplifiers and stuff built right on the rack, but with the nice custom aluminum frame, it was easy to handle. But that means more copper, and as everybody knows, the price of copper these days has just gone insane, and for this feed, I need like a 4-inch piece of copper pipe, and that's not hard to come by. And I didn't want to sacrifice the old feed. I want to keep it going in case this one doesn't work, and plus be out of commission on 13 centimeters. So went looking in the scrap bin. Well, fortunately for me, when I first became a ham, I got into the repeater business like a lot of us did. And an older ham had built this repeater and built this old duplexer system from out of the old ARRL repeater handbook. And they were made from six different copper tubes, which were 4-inch in diameter, perfect for this type of feed that I needed. Well, this whole thing is a pretty old set of homemade duplexer cans from way back when the early 70s, I'm going to guess. When I picked them up, it was 78, something like that. Come apart here. Wow, this is a bit apart. Chisel here. Now, see what we can do. There it comes. Okay. Tight. Oh, it's pretty cockeyed here. Oh, there was a screw. I didn't see that. Anyways, nice piece of copper. I believe it was Bill, V6BT, that built these way back when, and I redid them a little bit when I used them, and then I handed them over to another ham, and he used it for a while, and now we're just using it for the copper. So yeah, simple adjusting rod on the end, probably seized up. Oh, it's threads, that's right. Huh. The old early days of duplexers and VHF repeaters and stuff like that. What I'm going to use is this piece though for my new 13 centimeter feed. So get her cleaned up and cut her back and call her good for this part. So after a few revolutions, the old cutter, it finally came off, and this is the piece of pipe I need. I got to figure out the length and just continue cleaning it up. The pipe cutter leaves a bit of a mess. It's a pretty dull cutter. So there's quite a ridge in here. You can get her. I just got the paint off it. I'm gonna just give her a bit of a polish, make her look pretty. But this buffing type wheel works good for copper and aluminum. Anyways, yep. Sun's awfully bright right here, but makes it nice and spiffy. A bit of copper dust on there. Anyways, onward up for the next part. So the pipe is ready. They have holes drilled into it, so I dug out my rotary table here, and this is why you'll see why I left that metal plate on the bottom of the pipe. Oh yeah, I'm going to be cutting hairs here, but hey, this is one way of getting it rounded up. Using this. Go back here a little bit and put this on here. Somewhere in that area. Anyway, so then I'll take this, squeeze it in here. There. And I can start getting it true. Well, anyways, nobody said this pipe was true. I get it centered as best as I can. It's just so that it lays in the mill, more or less square with the world, but then again, not quite, so it'll do. So I got it on the rotary table and did what I can for getting it true. I mean, let's face it, this pipe is not perfectly round, but it's close. Close enough, you know, these things will be more or less square. I think it works out to be about, what, half a thousandth out? Yeah, I think that's what it was on the rotation part. So it's pretty darn close. I mean, a lot better than I could do with just a ruler. I'm probably cutting hairs here and getting real fussy, but yeah. You buy this stuff, you know, as a gear, you might as well use it, I guess, and hope for the best. So That's 1 thou, a little over 1 thou. Oh, there. I should go back. Or no, I'm sorry, 10 thou. Anyways, it's close enough. Jeez, can't see it otherwise. Okay, I'm trying to get this all in one video, so it's kind of zoomed back so you can see what's going on. But I'm going to pre-drill or pre-mark the holes for the polarizer screws. So this is how it's going to work. I got a 0 mark here, and we're going off the scale. This is depth, so the bottom display doesn't matter. So turn on the machine so the engine starting doesn't screw up my count. And we're at 0 there. So for my first hole is 125 millimeters in. So I'm right at the edge of my limit on this drill mill. It's just barely going to make it. 125, I'm getting there. I'm cutting hairs here again. Well, we'll just do the first one. 125. I'm just, like I said, I'm just more or less scribing before I start drilling holes. It gives me a kind of a center punch type of hole for the drill bit this thing to do. Next one's 152. They're 27 millimeters apart. That's 152. There. Plus this gives me an idea what it looks like. I'll know what's going to be bad or not. And next one's 152, 179. Close enough. Next one's 206. And the last one is 233. That's one side. Now the other side is 180 degrees. I've got a scale here, so I'm going to swing this thing at 180 degrees. So we're going backwards this time. 233 again, yeah. Stay the same. 206. Close enough. 79. Slop in this middle. 179. 152. I do the work in inches. I don't notice it's kind of playing millimeters. This is all millimeters. And that's at least 125 again. Good grief. 125. Okay, I'll swing this back to 0. Make sure we all line up again still. Notice that bit. There we go, there somewhere. And I'm right on the same hole, so good to go. For this part, anyways. This part I got to put in the holes for the end connectors, and they're 45 degrees on each side of 0. I'll get 0 here. We've got a 0 in there with 45 degrees. Lock it in, and then we're going in. 47 millimeters. I won't bother with the display this time. There. In the hole. And then we're going to go 9 degrees other direction. Go to 0. Come backwards. Oops, I bumped the camera, didn't I? Now we're still there. So it's 10, 20, 30, 40, and 45. Yeah, that's her. Sink her in. Yep. I think I got that right. I got to double check all this stuff. Anyways, there she is. Call her good. Now to double check everything before I drill holes in it. Okay, then finally we're going to start drilling holes in this thing, so I'm going to put a little dab of clean fluid on there and start it up. And away we go. Just look at that. Next one. Two. 6. Grab oil. And so on. You get the picture. Then we use the number 20 drill bit to tap these holes for the polarizer screws to be threaded for the brass bolts. pretty straightforward stuff. Nothing difficult about this. Then the last hole's all lined up and drilled it accordingly. And now the boring stuff. Takes quite a while. Get all this in there. Put some oil on this. And away we go. Back and forth. This definitely makes the bolts straight up and down in the tube though. You try and do this by hand, freewheeling it like, good luck. You never get it straight. This way, everything's going to line up just right. Yep. On to the next. Still using the digital scales, kind of keep things lined up. Should be anyways. I had to move a few things, so. Oh yeah, stood on my. Oh. Going on. Back to it. Easy as it can be. Of course, had to put a bolt in just to make sure it was lining up. You never know. So with all the holes drilled and tapped, all threaded, it was time to take it off the mill, put it back in the vise, and take this old plate off the bottom. It's been on there a long time. The solder's been on here a long time. Starting to flow in places. Which comes. Here she goes. Voila. I'll get this little solder off of here. Solder and paint and who knows what else. So the back plate finished, fitting nicely. I drilled a hole and a little later on solder a brass nut on this for the nulling post. I'll explain more of that later. Next we're getting the connectors mounted on this thing, and I built this special little brass bracket. I didn't do these videos in sequence, so they're going to jump all over the place. My lathe I use for whittling this thing away, it doesn't hurt to have a few odds and ends laying around. And yeah, you can never have enough scrap pieces of brass or copper or aluminum pipe laying around. You know, I should have tools laying in here, but this is the piece here I used for making that little brass goodie. So it pays to keep all this junk, I tell you. It pays off in the long run. And then you got to have assortment of goodies too, so it always helps. Anyways, I just thought I'd brag about that a little bit. So I forgot to video this part. This is the brass holder, we'll call it, for the hard line for the receive preamp connection. Boy, I can't even talk right now. Anyways, I drilled a hole in the darn thing and went on and on like that. I carried on, and I finally came up, and this is what I came up with, was this device. I took some, curved it, made it the right angle and all that stuff, and this is what becomes the mounting blade for the semi-rigid hardline for the preamp, or the isolation relay. Well, somebody's going to ask, how did I get the shape? Well, I laid a little bit around the corner there. I used a die grinder, and I just worked on it, put it on a pipe, tried it, on the copper pipe, tried it, and then worked on the angles and got it to fit the curvature of the copper pipe. And that's how it was done. So nothing fancy, just good ordinary patience and a little bit of grinding. Sandpaper flapper wheel, I guess you'd say. Nothing to it. Well, once I got the little brass piece shaped to fit on the pipe well, I just took a drill and, I had to get some markings or little dimples on the copper pipe to show me where to drill with the, I think it was a number 20. No, it's smaller than that. Anyways, for the 440 bolts, get them in there so I can thread the darn thing. That'll be next. So just carried on. Of course, threading copper is always fun. Using a good cutting oil helps, and yeah. Got the holes drilled, and everything fit for the 440 bolts. So I got the little brass plate made, all bolted down. This is where the semi-ridge is going to go to, and you'll be a dipole inside, which will be the center conductor. And then it'll go over here, and this is where it's going to go to the isolation relay. No connectors, one less connector, so try and squeeze every little bit of micro fraction of a dB I can for a noise figure out of this thing. Well, that's that one done. Next is the transmit port. The transmit port is just an end connector, and I've taken an ordinary end connector and I've just bent the ears over on two sides a little bit so it'll fit the curvature of the round can a little better. I'm just going to scribe in some markings for holes, and that's all it takes for this one. Relatively easy. Sure. We'll drill and tap them, and on we go. Well, there it is. To do connectors for the new 13 centimeter feed. That with the back plate, which will solder on the back side of it, if I remember right, sort of like that. And that part's finished. So next step is the launcher, the IMU launcher. So that's going to take some doing. First I cut out a paper template to make sure it looks like it's going to fit and do everything right, and then I got to go buy some copper flashing because I don't have enough to build that part. So this finishes that part anyway, so onward to the next step. This is the fun part, and a special thanks to Paul, W1GHZ, for his sweet little program. Without that, there's no way I could have ever figured out these angles and built this thing. With Paul's little antenna program, you enter all the particular information, like your FT ratio, your dish, and that has to be tweaked somewhat for it all to work. And after you do all that, it comes up with the flare angle you need, and also the suggested length for the launching section of it all. So with that information, I put everything on paper and cut it out to see if it was going to add up. I wasn't going to buy copper first and then do it. I put it with paper, put it on a pipe, and then make sure it's all going to fit. Then buy the expensive copper. So the copper flashing I'm using is, I got it from a local tin shop, and they use it for ornamental work. It's relatively thin and easy to work with, so I bought enough pieces to use and proceeded on making the IMU section. So, got some nice copper. Just going to put some marks in this thing, and I already 3D, good grief, printed it off in CAD so I could cut it out like I was showing you before. So, first dimension, first radius 3.46. Close enough. Good depth there. Put a scratch. Next radius 5.26. Guess I shouldn't be using my good scales for a scratch pad, scratch and post. Oh well, what are you gonna do? Now I need my scribe. Hoping he's up here. Should be. So. Like this is when it's nice and sharp. The first scratch. Oop. Just gonna make it. Yep. Yep, piece of cake. Piece of cake. A lot of copper not being used that you gotta pay for, but oh well. There. Don't know if you can actually see that, but maybe you can. Not very well. Anyways, I'm going to highlight it in black pen here shortly, and then I'll cut it out. So I got my lines cut here. I'm doing the rotation angles. Show me what part of the copper I got to cut out. So I needed. This is a start. And my pen does want to write, of course. Start here, go up. So that's 180. And I need 214 degrees, so that's another 34 degrees. Well, round off 35. So the protractor's here, and that's this one here. So this is the end. So I need all of this. So this I can cut out here. And then whole inner circle just to cut out. And all of this. cut. And keep. Here. So, just to keep it straight in my head. We'll get her cut out next, hopefully. Oh, I know, so we're going to do just a double check things here. This is my paper template that I cut out, so just to make sure I got the calculations figured out right. Yeah. Starts and ends there, so yeah, we're good. So we get to cut all this out. All this is going to go from here. That's all we're going to keep out of it. Sure, a waste of copper, but oh well. What are you going to do? This saw can do some of it anyways. Kind of loud. Too bad. And I saved a good chunk of copper too, so you never know. Could use for something. Oh, you're doing the fun part. shape. I made it a little bit longer, just to have something to work with, because it never works out the way it's supposed to. Yeah, about as much as I left longer, I have to cut off. I will do the extension first. But, it's getting there. It's easier to do in the paper. The paper wouldn't stay in place, where the copper bends nicely and stays in place. So I think it's about as good as we're going to get it for now, until we get the other part built. Enough. I got an extra piece cut because that's going to be the clamping section. Like that. Bring myself a scribe. I can use the compass. This is a simple rectangular piece of copper that I cut out and won't turn into the launcher. But first, there's a couple of more things I have to do before I can put this together. So all the pieces cut, the next was to solder it all together, and how do you hold it all together and keep things round, I guess we'll say. So a few more things to build. One thing I did learn from building IMU sections for the higher bands, like on my 9cm, 6cm, was that things have got to be really concentric, or the pattern's going to be off, as far as I know anyway. So this is what I think. So I built some templates for everything to fold around on and then solder together, as you'll see. Blade's getting way too dull. So another plan of attack. Yeah, let's plug it up. This would be easier. It's got a way coarser blade on it. We just got to hang on to it. That's the only problem. So the two discs are cut roughly a little bit bigger than what the inside diameter of the launcher section is supposed to be. So onto the lathe. Should be it. Six point 6.26. Just what I want. So that's number one. So the two discs were nicely trimmed for the outside diameter. Now it's the inside hole, and it's getting it set up for the lathe. That's going to take a bit. Doing this was just a simple bolt in the center, but now the outside has to be clamped too, and my little 3-jaw chuck just won't quite make it for this big a diameter. installing this much larger 4-jaw chuck is a bit of an undertaking, I'll tell you. So I got the large chuck on the lathe, and I got to get it. You know, this is not like the 3-jaw chuck. This is our individual jaws of this chuck, so it's a pain in the butt to true. And I can't go on the outside. I got to true it on the outside so I can bore out the inside, and I can't do that because of, well, bang, eh? So I don't need it that accurate. So I just came out of here like this. Got it zeroed close on top of the jaw. I just ran it for 0. And then I just kind of went like this. Oops, I went too far. Just hold it up a little bit, don't lose count. Go to the next one. Did that, went back and forth. And as I needed it, I would just tighten this and loosen that. And I got it, you know, pretty darn close, as long as the distance from here to here is the same. And it's off a little bit there, but I'm talking, what is that, 1/1000 of an inch? I don't need to be that accurate, so it looks pretty darn good. So truth of the pudding is we'll crank this up, we'll turn it on, and the outside ring, I don't know if you can see it in the camera, but it looks pretty darn good. I just got to bore out the center now, and that'll be for this one. Then on to the second one. You'll see what this comes to eventually. Okay, we can start rounding this thing off a little bit. I'm going to be in the way of the camera here, I see. Oh, that's my head's in the way. Now we'll try it. Just a little at a time. Should do it. Go back for a few times. Measure it now. Should be close to 4 inches. Four inches on the nose. I find this odd. Maybe it's from the pipe cutter when I cut down the pipe, but it fits, but it's tight at first. Well, I get down there and it's good. So, for some reason the top of this pipe is out of shape a little bit, but that's okay. It'll work. Number 1 done. So this is the end result of these discs being made here, bolted together with these ready rod acting like spacers, and it's going to slide over the popper pipe, and then the copper sheet will wrap around that for holding it in shape while soldering. So this is the plan of attack. You can see what I've shaped here. And that sand along the edge. One thing I forgot though was to put a little bit of flux on this. I almost forgot. Flux goes a long ways. So I've pre-shaped this a little bit. I'm trying to remember how I did it. Yeah, that's pretty good. See my plan of attack here. farther down actually. Take a little bit of heat. There she is. So once we get things hot here, liquid flux. It's soaking good. Well, got the clamps off her, and I'll buff this down later because there's more to solder yet, but it's going to be fun getting it out of there. She's in there tight, but once I take the bolts out, I can even cut that aluminum out of there, I think, so we'll see. It should be interesting. So next step is this, and then a clamp. I got to build a clamp yet. It's coming along. So you can see I've got it clamped onto the waveguide as a jig, and I'm going to start the top part clamp I built already. It's a clamp tube, and then the flange here. So I'm going to start tacking along the way and get it in position. So here's hoping. Tricky to get it tacked. Now where I can trim this is a bit long. Oh, there, anyway, that's one thing to think about it. So tack her over here now. View. Oh, yeah. Oh. I'm gonna knock this down just a bit. Jeez. If I caught that, that would have been hazardous. It's not touching over this top part here at all. Well, we got a gap there, so I'm gonna get this out of here somehow again. Oh well. This is gonna take a bit, so we'll stop it here. Well, I think I'm getting somewhere. Someone here. Do a little trimming. So we're going to try again. Oh, damn tricky trying to get this thing to solder together. Of course. time to tack it. So now I got to turn the hose clamp down. We'll see if we can solder it here without undoing that. I can just see this going boing, but oh well. We'll see. At least it's up in the air a little bit here. Yep, just like I said, there it went. Ah, man. Anyways, you get the idea. So I was taking the bolts off and take one plate out because I'm scared it's going to be soldered to the waveguide, but believe it or not, it didn't. Oh, I'm lucky. Still not coming off all that easy, but it will. Anyways, I thought I got the spacers out of there, and there it is. Not too much on view. Not too bad inside. I was afraid the solder would have leaked in here and stuck to the main waveguide. I was just depending on the main pipe not getting hot enough for the solder to stick to it. So now I've got to work the surface down, get all the gobs down a bit, and it's going to look like here, like this. Let's go from here. Let's go here like this. Voila, feed horn. What can I say? Worked out pretty darn good, better than I thought it would. Crazy thing. Oh well, there you go. So, it's not bad, but I'm just going to knock down the solder some and clean it up a little bit and see what happens. I don't think we'll do it, but it'll get there, I think, eventually. Not too much on the inside. We'll round it all off and make it look pretty. Just going to clean up a bit with the wheels here and see how it all turns out. See if I can get in focus. Anyways, you get the idea. Here we go with the compressor. It's kind of look pretty, you know. So we'll carry on, but I'm not going to do all this video on this. It's just too much and too loud. So, got her knocked down. I don't want to take too much solder off because that's all it's holding it together. But you can take quite a bit off and make it look smooth. Got to make it look pretty, so take this one off. Put this one on with a nice wheel. A lot of water coming out of my compressor here. I just cleaned it out. Yeah, anyway, so coming in focus. Oh, more or less. like the idea. It looks pretty. I might even take some steel wool later and polish it up. It'll get it done. It's gonna look good. That's the important part. It's gonna look good too. So with the launcher section finished, there's one more thing left to do for soldering is the back plate. Get the little brass nut soldered to it, and then the plate itself to the back of the waveguide tube. So here we go. It's easy enough to solder, clamp, hold it in place and all that, but those of you know how to build these feeds, you notice the null tuning bolt? I got it on the wrong side. The back plate's 180 degrees out of position, so later on I had to tear it off and reposition it. But just another skip moment. Yeah, just to keep the excess solder. Yeah, that's how it's done. Looks real nice and neat. I made sure I got that in the right spot. One time I saw it over here. It's supposed to be down there. Oh boy. Oh well, like I said before, I have some doozies of days, so good enough. Well, I've been dragging this out way too long, so we're almost finished. What's next to build is the different RF probes for the waveguide itself. This is the transmit probe, pretty straightforward. I just bent the ears on the two corners of the end connector so it would fit the curvature of the pipe better, that's all. This is a receive probe, and like I described before, it's just a piece of small rigid line that is soldered into that custom brass holder that fits on the curvature of the pipe. The center conductor itself is the probe. Doing away with one connector just to help the losses, if you know what I mean. I need everything I can on receive. So that's it for the two probes. Nothing special. I've done it this way for my other feeds, so it works well. Why reinvent the wheel? So this is with it all put together. All the polarizer bolts to put in, the end connectors, the receive line connector, and the plate on the back with a nulling post. Take note, I had to take that back plate off and spin it around 180 degrees like one of my skip days. I had it backwards, but it's all good to go now. So this is the new waveguide feed. Anyways, you can see the receive probe and the transmit probe and the polarizer bolts hooked up. So now the main part, the IMU launcher. It's got to go on here. A little tricky, maybe. Oh no, went on like a charm. I'm gonna harv that pipe in there. Oh, too far. Yeah, it goes on, but it doesn't want to come off very well. There we go. Right there. Clamp. To look like in the view, not bad. Oh, she's built. Just got to tune her up, and that'll be next. Kind of different looking from fall off. This old thing. That's the old one. Here's the new one. Oh. Wanted to get rid of all this. The other tube is much quieter from what I've seen on the other bands, so this is the old one. So next we'll be tuning all these up, getting the probes tuned and the polarizer approved. So it'll be interesting. So that's probably in the second part of this, because I don't think I'm gonna get all one video. So anyways, that's how you build one of these contraptions. I know it's one way of doing it, I should say. So here you go.